The city had learned to ration light the way it once rationed water, carefully, grudgingly, with a quiet shame it could not name. By the autumn of 2031, New Meridian ran on 4 hours of grid power a day. The rest was managed chaos, diesel generators coughing black plumes above rooftops, solar arrays on every surface that could bear them, and the low electronic hum of priority systems, hospitals, data centers, police towers, drawing what remained. The skyline still glittered at night, but only in patches, like a face with missing teeth. Ethan Cole had grown up in this city. He was 31, a freelance infrastructure journalist, and he had spent the last 5 years documenting the slow collapse of the electrical grid, first as tragedy, then as routine, and finally as background noise. He wore a power bank on his belt the way his grandfather had worn a wristwatch. His apartment had no oven, only an induction plate that he used in bursts. He tracked the rolling blackout schedule on a worn paper calendar pinned above his desk, the way people once tracked bus routes. He did not think of himself as someone living through a crisis. He thought of himself as someone living. That distinction, he would later understand, was the first thing the Amish had already worked out. The assignment had come from a small but well-regarded magazine called Ground Current. His editor, a precise woman named Miriam Holt, had handed him a single printed page, unusual in itself, and said only, "There are rumors. Go and see." The rumors were about the Stoltzfus settlement, an old-order Amish community 40 miles east of the city, deep in the farmland that the suburbs had not yet swallowed. The rumors said they had power, not solar, not wind, not any kind of power the grid had ever recognized or the authorities had ever approved. The rumors said they had something that made no sound and consumed no fuel, and that their barns were lit all winter like lanterns in a painting. Ethan drove east on a Tuesday morning, past the outer ring of the city where the power cuts were worst and the faces on the streets were most tired. The highway thinned. The billboards, half of them advertising energy management apps or portable generators, grew sparse and then disappeared. The land opened up. Brown fields, fence lines, the occasional white farmhouse sitting in the flat light like a sentence with no punctuation. He passed a sign that said Hartwell Township, population 1,240, and turned onto a gravel road that his city program navigation refused to recognize. He drove by instinct and by the hand-drawn map Miriam had included, also unusual, until he saw, at the end of a long lane of oaks, the first of the Stoltzfus farms. A man named Samuel met him at the gate. He was perhaps 60, with a gray beard trimmed close and eyes that held the particular patience of someone who measured time in seasons. He wore a plain dark coat and a wide-brimmed hat, and he shook Ethan's hand with the dry, firm grip of someone who worked with his hands every day of his life and saw no reason to make ceremony of it. "You came about the engine," Samuel said. It was not a question. He led Ethan to the barn behind the main house, a large old structure with hand-hewn beams and the sweet smell of hay and timber. Inside, the usual things. Tools on pegs, a workbench worn smooth with decades of use, a cast-iron stove in the corner, and then, in the center of the room, sitting on a low wooden platform as naturally as a millstone or a butter churn the engine, it was not what Ethan had imagined. He had imagined something impressive, something that announced itself. This did not. It was roughly the size of a large barrel made of dark gray metal with no visible fuel inlet, no exhaust pipe, no cooling fan. It had a single shaft emerging from one side, connected by a leather belt to a small generator. A cluster of copper wires ran from the generator up through a hole in the barn wall. It was running. He knew it was running because the belt was turning, slowly and steadily, and the faint light in the barn, 4 bare bulbs hanging from the rafters, was burning without flicker. But the engine itself made no sound he could identify as mechanical. There was a low hum, barely above perception, like the sound of blood moving in a quiet room. No combustion, no heat that he could feel from 4 feet away, no vibration in the floorboards beneath his boots. "It has been running since my father's time," Samuel said beside him. "We have not added anything to it. We have not taken anything away." Ethan stood looking at it for a long time. He had written about energy for 5 years. He knew the physics, the economics, the politics of it. He knew what was possible and what was not. And yet the machine sat before him with the indifference of something that had simply never received the memo about impossibility. He took out his recorder, then stopped. He put it back in his pocket. Some things, he felt, needed to be understood before they were reported. Later that afternoon, Samuel's daughter, a young woman named Ruth, who had, Ethan would learn, studied mechanical engineering for 2 years at a state college before returning home, poured him black coffee and sat across from him at the kitchen table. Through the window, the fields were silver in the fading light. "People from the city always look at it the same way," she said. "Like it's broken, like there must be something missing." "That's because there is," Ethan said. "Or there should be." "That's the first difference," Ruth said. "You think something that works quietly must be hiding a secret. We think something that works quietly is simply working well. He thought about the city he had left that morning, the hum of generators, the competing noise of 1,000 compensating systems, the elaborate technological scaffold built to keep the lights on for 4 hours while the underlying grid continued to fail. He thought about the way the power bank on his belt had become as natural as breathing, and how he had stopped noticing the smell of diesel on Tuesday evenings when the co-op building ran its backup units. He thought about the barn, and the belt turning, and the 4 bulbs burning. The engine asked for nothing. It offered only the steady, indifferent gift of motion, gravity cycling through its chambers in some arrangement that no one in this household fully understood, and no one in this household felt they needed to. It had been built by a craftsman whose name was carved in the base plate in German script. It had outlasted its builder by 4 decades. It showed no signs of stopping. Outside, a horse moved along the fence line. A child called from somewhere across the yard. The kitchen smelled of wood smoke and bread. The single light above the table burned clean and constant, drawing its power from the silent machine in the barn, which drew its power from what, exactly? Samuel had tried to explain it in terms of counterweights and angular momentum, and Ethan had understood most of the words, but not the whole. Ruth had said simply, "Gravity doesn't run out." In the city, they were rationing 4 hours of electricity per day and calling it a managed crisis. Here, in a kitchen 40 miles east, with no grid connection and no fuel tank and no solar array visible from where he sat, the lights simply burned. Ethan opened his notebook. He wrote 2 words at the top of the first blank page and then stopped because he didn't know what to write next and because he understood, for the first time in 5 years of writing about energy, that he was looking at something he did not yet have the right language for. The 2 words were, "It works." The blueprint was not paper. It was linen. A square of tightly woven cloth, stiff with age and the residue of 100 careful tracings, pinned flat against the barn wall with 4 wooden pegs. Ruth brought a lantern and held it close while Ethan studied the drawing. It had been made in pencil first, then gone over in ink. And in places where the ink had faded or the pencil lines had smudged, someone, several hands, over several decades, had retraced the relevant section in a slightly different weight or angle, so that the blueprint read like a conversation across time rather than a single fixed document. At the center of the drawing was the engine's main assembly, rendered in careful isometric projection. A squat cylinder, roughly 18 inches in diameter and 24 inches tall, its interior shown in cross-section. Inside, a vertical shaft ran from top to bottom, fixed at both ends in brass journal bearings. Around this shaft, at carefully spaced intervals, hung the counterweights. 8 cast iron segments, each roughly the size and shape of a large book, connected to the shaft by articulated arms of wrought iron. The arms were not rigid. They were hinged at 2 points, once at the shaft and once at the weight itself. This double hinge was the key. As the shaft rotated, centrifugal force caused the arms to swing outward, lifting the weights away from the vertical. But the weights did not simply fly outward. They were linked by a system of brass chains and counterbalance springs that converted their outward motion into a downward pull on a secondary gear train. This gear train, through a cascading reduction ratio of approximately 48.1, turned the output shaft at roughly 6 rotations per minute, slow, steady, and with considerable torque. The leather belt connected to this shaft ran to the small generator, which required only modest rotational force to produce the 112 watts that powered the Stoltzfus farm's lights and small appliances. The engine belongs to a class of devices sometimes called gravity motors, or weighted flywheel machines. Its operating principle exploits the asymmetric displacement of rotating masses. When the arms swing outward under rotation, the system's moment of inertia increases. By linking this outward movement to a gear train via chains, the machine converts the change in inertia, rather than simple weight drop, into sustained rotational force. The critical insight in the Stoltzfus design is the double articulated arm. Standard flywheel designs allow weights to swing to a single equilibrium point and remain there, canceling any net torque. The double hinge introduces a phase offset. Each weight reaches maximum extension at a slightly different point in the rotation cycle, maintaining a continuous asymmetry. The result is a torque curve that never reaches zero, a small but uninterrupted rotational force that, through the 48.1 gear reduction, becomes usable mechanical output at the drive shaft. Energy audit, approximate. At 6 RPM output with a 4-inch pulley driving the generator, belt speed is approximately 6.3 feet per second. At the generator's tested output of 112 watts, the system efficiency from shaft to electrical output is estimated at roughly 71%, consistent with a small permanent magnet generator of this type. The mechanical input required at the drive shaft is therefore approximately 158 watts, or about 1/5 of 1 horsepower. The inscription on the base plate read, Ezra Stoltzfus, Hartwell, 1887. Below it, in smaller letters, a single line in German, was Herabfeld kann nicht lügen. Ruth translated it without being asked, what falls cannot lie. Ezra had been a clockmaker, or had trained as one in Lancaster, before the family moved to Hartwell in the 1870s. The Amish tradition had always maintained a quiet affinity for mechanical systems that required no external energy source. The grandfather clock, running on nothing but a descending weight and a pendulum's patient arc, the watermill, drawing its power from a stream that would flow regardless of human effort, the windmill, turning when the air moved and resting when it did not. These were not primitive technologies. They were technologies that had been refined across centuries to extract maximum work from freely available forces: gravity, flowing water, wind, without combustion, without fuel, without the dependency that fuel creates. Ezra had understood this inheritance deeply. His clockmaking training had given him a precise vocabulary of gears, escapements, and regulated motion. His familiarity with watermills — the settlement had operated 2 along Hartwell Creek since 1848 — had given him a practical understanding of torque, gear ratios, and load balancing at scale. What he built in 1887 was not a departure from these traditions. It was a synthesis of them, a clock's precision married to a mill's power output, driven by the same gravity that had run both for centuries. The original machine had operated a grain mill, the same function as Hartwell Creek's water mills, but independent of water availability. When the creek ran low in dry summers, the gravity engine ran regardless. It had been converted to electrical generation in 1931, when Ruth's grandfather, Jacob, had fitted the leather belt and small generator during a period when the regional utility had tried to extend its lines into the settlement and the elders had declined, politely and permanently. The elder's name was Abner. He was 83 years old, and he sat in a cane-backed chair near the barn's east window with the stillness of someone who had long since made his peace with the pace of things. His beard was white and long. His hands, folded in his lap, had the look of hands that had repaired and adjusted and maintained the same machine through 4 decades of seasons, and knew it the way a musician knows an instrument, not by memorizing it, but by feel. Ethan sat across from him on an upturned crate. Ruth translated when needed, though Abner's English was better than he let on. "You want to know how it works?" Abner said. It was the same phrasing Samuel had used. Ethan wondered if it was a Stoltzfus habit, the quiet substitution of a statement for a question, as if to spare the visitor the embarrassment of having asked something obvious. "I understand the mechanics," Ethan said. "I'm not sure I understand the—" He stopped. He wasn't sure what word he was looking for. "The patience of it," Abner said. Ethan looked at him. "A machine that runs on falling things must be built to fall slowly," Abner said. "Slowly and always. You cannot have both fast and forever. You choose one." He paused, looking at the engine. Ezra chose forever. Gravity does not run. Gravity does not rest. Gravity simply continues to be what it is, whether you use it or not. A man who builds with gravity does not need to hurry. The force will be there when he is ready. It will be there when he is not ready. It is the most patient thing in the world. Ethan wrote this down. Abner watched him write it with the expression of someone who has said the thing many times, and long ago stopped wondering whether it would be understood. "The cities," Abner said after a while, "they build machines that require more energy to run than the energy they are trying to find." He said this without judgment, or with a judgment so old it had become indistinguishable from observation. We do not build like that. Later that evening, with Ruth's permission, Ethan opened the engine's side inspection panel, a hinged plate secured by 4 hand-forged bolts, and studied the interior with a flashlight while she named the components from memory, the way a child names the rooms of a house they grew up in. The central shaft was mild steel, 3 inches in diameter, machined to close tolerance and polished to a near-mirror finish where it ran through the journal bearings. The bearings themselves were bronze, packed with beeswax thickened tallow, a lubricant formulation. Ruth noted, unchanged since Ezra's time, which required replenishment roughly twice a year. The 8 counterweight arms were wrought iron, each measuring 14 inches from the inner hinge to the outer, with the weights, each approximately 11 pounds of cast iron, secured at the outer end by a tapered pin and collar. The brass chains connecting the arms to the gear train were fine-linked and precisely tensioned, adjusted by small turnbuckles whose threads still showed the marks of Ezra's original calibration tool. A wooden jig hung on the wall above the workbench. The gear train was the most intricate part. First reduction, a 24-tooth pinion driving a 96-tooth wheel, a 4:1 ratio. Second reduction, a 16-tooth pinion on the same shaft as the first wheel, driving a 48-tooth wheel, a 3:1 ratio. Third reduction, a 12-tooth pinion driving a 36-tooth crown gear on the output shaft, a further 3.1 ratio. Combined, 4 x3 x3 for 36.1, not 48.1, as the blueprint indicated. Ruth looked at the discrepancy when Ethan noted it, then nodded. Grandfather changed the final stage in 1953, she said. The original third stage was worn. He replaced it with what he had. It runs a little faster now. It was a detail so ordinary, a repaired gear, a small adjustment, an inherited imperfection, that Ethan found himself unexpectedly moved by it. He machine was not a relic. It was a living thing, modified and maintained and corrected across 5 generations, carrying within its construction the cumulative knowledge of everyone who had ever put a hand inside it. The blueprint on the linen cloth was not a record of what the engine was. It was a record of what the engine had been, a starting point, revised continuously by the quiet, careful work of people who understood that maintenance was not a chore, but a form of respect. He closed the inspection panel. The bolts went back in the same order they had come out. The belt continued to turn. The lights in the barn continued to burn. Outside, the stars were out. There were more of them here than in the city, more than he had seen in years, because there were no competing lights for 40 miles in any direction. It occurred to Ethan that this too was a form of the same principle. In the absence of noise, the signal becomes clear. In the absence of excess, what remains is only what is necessary. He stood in the yard for a long time, looking at the sky, while somewhere behind him in the barn the engine turned, and the weights described their slow, ancient arc, and gravity continued, as it always had, to fall. He drove back to the city on Wednesday morning with the engine's hum still living somewhere in his chest, a memory of sound, or the absence of one, that he could not quite locate or dismiss. By Thursday afternoon, he had written 14 pages of notes that he could not yet arrange into a story. By Friday evening, he had called Miriam and told her he needed more time. She had given it to him without asking why, which meant she already suspected what he was sitting with. On Saturday, a man named Gerald Voss called his personal number. Ethan did not know how Gerald Voss had his number. He did not ask. Voss introduced himself as a senior acquisitions director at a company called Meridian Energy Solutions, one of the 3 largest grid management corporations operating in the northeastern corridor, a company whose name appeared in the municipal blackout schedules and on the diesel generator contracts taped to the walls of half the buildings in New Meridian. His voice was pleasant and precise, the voice of someone who had spent 20 years being paid to sound reasonable. "We understand you've been visiting the Hartwell settlement," Voss said. Ethan said nothing. "We have research teams that monitor rural energy anomalies," Voss continued. "The settlement has appeared in our data for some time. Low grid usage, 0 in fact, no solar signature, no wind infrastructure, and yet thermal imaging shows consistent interior lighting through winter months. That's not unusual for Amish communities," Ethan said. "They use kerosene." "Kerosene produces a different thermal profile," Voss said, with the patience of someone correcting a student who already knows the answer. "We'd like to arrange a consultation with you and with the community, if that can be facilitated. We believe there may be a significant commercial application here, one that would benefit everyone involved." Meridian Energy Solutions had filed 17 patents in the previous 4 years covering gravity-assisted mechanical generation, all of them exploratory, none operable. A working prototype would allow them to file manufacturing patents, control licensing, and position themselves as the dominant provider of a technology that, unlike solar or wind, required no geographic conditions and no ongoing fuel cost. At the scale Meridian operated, grid contracts across 6 states, infrastructure in 42 municipalities, a licensable gravity engine would be worth, conservatively, several $billion in the first decade. The Stoltzfus family would receive at best a one-time consultation fee and perhaps a small royalty arrangement negotiated by lawyers they had never met, covering a technology their ancestor had built by hand in 1887 and that they had maintained in quiet obscurity for 144 years, precisely because they had no interest in what Meridian was describing. Ethan told Voss he would think about it. He ended the call. He sat for a long time in his apartment, in the dark. The rolling blackout had taken his grid power at 6:15 as scheduled, listening to the diesel generator in the co-op basement begin its evening cough. He drove back to Hartwell on Sunday. He had not called ahead. He did not know exactly what he was going to say. He knew only that the decision he was carrying belonged partly to the Stoltzfus family and that he had no right to make it alone. Samuel met him at the gate again, with the same unhurried expression, as if Ethan's return had been expected, or as if, in a community that measured time by seasons, the difference between expected and unexpected had long since collapsed into something simpler. The man is here, or he is not here, and either way the work continues. Ethan told him about Voss. He told him about Meridian. He laid it out plainly, without editorializing, the way he had been trained to report. Here are the facts, here is what was offered, here's what I understand to be at stake. When he finished, Samuel was quiet for a while, looking at the fence line. "You are asking us what to do with what you know," Samuel said. "I'm asking what you want," Ethan said. "It's your engine, it's your family. Whatever I write, or don't write, affects you, not me. Ruth came out of the house then, as if she had been listening from the porch, which she probably had been. She stood beside her father and looked at Ethan with an expression he had not seen on her face before. Not the patient amusement of someone explaining the obvious, but something older and more careful. "If you write about it," she said, "they will come. Not just Meridian, all of them. And they will not ask." "I know," Ethan said. "And if you don't write about it," she said, "the cities stay dark." "They were already dark before we had the engine," Samuel said quietly. "We did not make them dark. We cannot make them light. That is their work, not ours." Ethan drove back to the city that evening with the decision still unmade. He ate dinner alone, checked the blackout schedule for the following week, charged his power bank from the building's solar reserve, and went to bed. He lay awake for a long time. What he kept returning to was not Voss and not Meridian, and not the patent implications or the licensing arrangements or the geopolitical weight of a fuel-free power source. What he kept returning to was Abner, sitting in his cane-backed chair in the barn's east window, and the thing Abner had said: "You cannot have both fast and forever." He thought about what the cities would do with a gravity engine. He thought about the speed with which a working prototype would be scaled, patented, litigated, reverse-engineered, reproduced at cheap tolerances, sold in 100 inferior versions, embedded in a supply chain that would recreate every dependency and fragility it had been intended to replace. He thought about how quickly a simple thing becomes complicated when complicated people get hold of it. He thought about the linen blueprint. He thought about the beeswax tallow in the journal bearings. He thought about the replaced gear that no longer matched the original specification and had worked perfectly for 70 years regardless. At 2 a.m, he opened his notebook to the first page, where he had written the 2 words on his first visit to Hartwell. "It works." He sat looking at them for a long time. Then he turned to a fresh page and began to write, not his article, but a letter, to Samuel and Ruth and Abner, telling them what he had decided and why, and what he thought they deserved to know about the world that was circling their fence. The article Ethan published in Ground Current 3 weeks later was not about the engine. It was about Amish energy philosophy, the broader tradition of gravity clocks, water mills, passive cooling, and non-extractive mechanical systems that communities like Hartwell had maintained for more than a century, while the rest of the country built infrastructure that consumed more energy managing itself than it reliably delivered to the people who needed it. It was a good article. It was honest and precise, and it named no individual and no specific location. Miriam ran it as a cover feature. It was widely shared and carefully forgotten within 2 news cycles, as most good journalism is. Voss called once more, shortly after publication. Ethan did not answer. He did not answer the second time either. After the 3rd attempt, the call stopped. What Ethan did not publish, and what he never discussed with anyone except in the letter he had sent to Hartwell, and in a sealed addendum filed with his personal archive, was this. In the weeks following his visit, he had run the engine's specifications through the engineering contacts he trusted most. 3 of them, independently, had said variations of the same thing. The design was not impossible. It was not magic. It was not a free energy device in the thermodynamic sense. It operated within physical law, drawing on the continuous potential energy of its weighted system in a way that, under the right conditions of mass, geometry, and gear reduction, produced a genuine and sustained mechanical output disproportionate to what naive analysis would predict. It could be replicated. It would take a skilled machinist, quality materials, and several months of patient calibration. It would not scale to power a city, but it could reliably and indefinitely power a farm. That distinction between what a technology could do and what the world wanted it to do was, Ethan had come to understand, the entire lesson of Hartwell. Ezra Stoltzfus had not built a revolution. He had built a sufficiency, something adequate for the life it was meant to serve, no more and no less, all maintained across generations by people who understood that the purpose of a machine is not to grow, but to endure. The engine was still running when he sent the letter. It was still running the last time Ruth wrote back. He had no reason to believe it had stopped. Gravity, as Abner had said, does not rest.